So now we'll understand the comparison between internal BGP, IBGP, and EBGP. So we'll explore what are the differences, benefits, and the uses of this IBGP and EBGP. What is IBGP? IBGP means the BGP inside the A's that we have already configured. But if you are having different A's, like different companies, so definitely they are having different A's. So if you have that, then you want to configure EBGP. So what is IBGP? That is internal BGP. It is a specific implementation of the BGP protocol designed for use within a single autonomous system. So it actually facilitates the sharing of routing information among routers, and it ensures that inside an ACE, like inside a company A, there is an IBGP. So inside the company A, there is the internal BGP that is running, and all the ASs, that is separate AS are there, and inside that AS you have that routers that residing, and they're configured with the IBGP. So what are the characteristics of IBGP? Full mesh requirement, root reflection, that is root reflector that we configure, and low loop prevention. So let's go into those details. First is full mesh requirement. What do we mean by that? All IBGP routers must be interconnected in full mesh topology, because full mesh, these are actually the parts of avoiding the loop. So in the loop prevention mechanism, first you have full mesh. You establish the full mesh requirement in the IBGP. And this requirement can be resource intensive, especially in large networks. That is a downside, because if you're having too many routers, say for example, then full mesh connectivity, it should be costly. Another way to prevent loop is root reflection or root reflector. Like, to alleviate the scalability issue caused by full mesh, root reflectors can be implemented. Like, root reflector means that there is a single, say, router or the root reflector, and others are root reflector clients. So if any root needs to be propagated, then it won't be shared within the clients. It would be reflected to the root reflector. It will be sent to the root reflector server, and the root reflector server will reflect, or it will send back to the root reflector client. So it will be a via communication, and it will prevent the routing loop occurrence. Then no loop prevention. IBGP does not incorporate mechanism to prevent routing loops within the same autonomous system. This can lead to potential routing inefficiencies or loops. So even though the IBGP has this full mesh, but it has no such loop prevention as compared to the EBGP. So what here it is telling you that it doesn't have that solid mechanism. Like in EBGP, we see that its ACE path attribute is there. Like if you're sending one update from one ACE to the other ACE, then you calculate the ACE path. That if I receive the routing update from the same ACE, like the source ACE, that will be discarded. Means the same mechanism is not there in the IBGP, but definitely these methods are there for loop prevention in case of IBGP, but they are not that smart enough. Now, what is EBGP? External BGP is a crucial routing protocol that facilitates the exchange of routing information between different A's, like that I was talking about. If two companies are there, then company A has one A's, company B has another A's, and if you merge, then it will be EBGP configuration. It ensures efficient communication and data transfer across internet by merging two networks or two A's. What is the characteristic of EBGP? Direct connection means EBGP peers are typically connected directly to one another, which facilitates faster communication. Means in EBGP you can have indirect relationship also, or indirect neighbor. Like if R1 is connected to R3 in indirect manner, it is not connected directly. In OSPF or EIGRP, what we do, we can establish neighborship if that is directly connected only. But in EBGP or in any BGP, let it be BGP or IBGP, whatever you say, we can have the indirect relationship. But direct connection is better because it is faster, but also you can have indirect. Then ACE path attribute is there, that is critical in BGP as it records a sequence of A's that router has traversed. So that I was talking about, that if the source is that one I have received, I will discard it. This information helps routers avoid creating routing loops, and this is a very smart approach. It is smarter than the IBGP that is full mesh. This EBGP loop prevention is very smart approach. So these are the things that we have to remember in the basic IBGP versus EBGP. So already we have configured the IBGP in the previous video. Now here I'm going to show you just how to add EBGP. Already the IBGP connection is there, that is running, but we will configure another AS. We configured AS10. Now I configured say AS20, and then I will make connection between IBGP and EBGP. So let me take you to the Genesis 3 console back. So this is the thing. This is the diagram that is running, and we already know between R1 and R2 that is the IBGP relation, and we have added R3. Now here it is 192.168.0.10.2 and 10.0 loopback 20.0. But here I'm going to configure, these are the routes that you can see. Here I'm going to configure another interface, and that interface is F1 by 0. And let me show you the show IP interface brief. You can see that 192.160 is there. So let me configure 192.160 network for this F1 by 0. So go to interface F1 by 0, shut, and IP address is 192.168.1.1. Go to R3, F1 by 0 should be 1.2. One nine two one sixty eight 1.2, and the other way here F1 by 1, it would be, let's say, 2.1 and 2.2. So this R2 can be the 2.1, the F1 by 1 here. Configuring 192.168 2.1, and here F1 by 1 it would be the 2.2. Interface loopback 0. This IP address is 30.0.0.1. So I'm configuring the EBGP between R1 and R3 and R2 and R3. The router BGP plus 10 and add neighbor as 192.168.1.2. Remote AS, let's say 20, because on the R3, let's say the AS is 20. And on R3, you go to router BGP is 20, and you add neighbor as 192.168.1.1 and remote AS 10, that is here. And on R2, router BGP 10, neighbor 192.168.2.2, remote AS 20, and similarly here, see the previous neighbor is up, and here the neighbor 192.168.2.1 sorry, it's 2.1, and remote is 10. So you have added, but we haven't advertised the networks in the R3. So advertise device always up. Now advertise the network. Network would be first 192.168.1.0. Mask would be 255.255.255.0. Another network would be the 192.168.2.0. Mask would be the same. And another one would be the loopback, that is 30.0.0.0. And the mask would be 55.0.0. It's a typo, so it should be network. And now on R1, the network that you should advertise, the BGP, that is the 192.168.1.0, the mask. And on the, you can say there is R2, the router BGP 10. You have to advertise the network as 192.168.2.0 network and the mask. And it's done. Now if you just see show IP route, you can see that the BGP, all the routes 30.0 has come. Previously it wasn't there, and the 192.168.2. And if you just filter it out and see the route show IP route BGP, you can see this BGP 10, 30, 192.168.1, all the routes. And also the show IP BGP, the BGP's routing table, you can see all the 10, 20, 30, all the networks of the BGP and its next hop. Similarly, if you go to the R1 and if you see show IP route, then you can see all the BGP 20, 30, 192.162.0, all the prefixes. Similarly, you can only see the show IP route BGP, the BGP's route, the 20, 30, 192.162, everything is there. And also you can see the show IP BGP, the BGP's routing table, 20, 30, 192.1.0.1 to everything. As well as you can go to the R3 and you can see show IP BGP, that is the R3 that we have added. There's a new AS20, you can see the all the prefixes there, and show IP route BGP 10, 20, and 192.1.0. Every route is there, and show IP route. So there also you can see that BGP has everything, the 0.0, 1.0, 2.0, every route, 20.0, 10.0, every route is there. So that is how you configure the eBGP. So previously we have configured iBGP, and now here we have configured the eBGP. So iBGP and eBGP is fully functional. So that is it about iBGP versus eBGP. I will see you in the next video.